Today we're going to discuss how the mass of an object affects acceleration. Now, in order to understand, we have to realize that in this scenario, force is going to remain constant. The force applied is going to be the same for all the different shopping carts. All right, and you should remember that constant means remains the same. Okay, now let's draw our shopping carts. Okay, where are we? Oh, for some reason that wasn't, lost my pen. We are a 400 kilogram shopping cart. We throw a bunch of groceries in and increase the mass of the shopping cart to 800 kilograms. And we fill it up even more to increase the mass to 1,200 kilograms. So the variable that's being changed is the mass of the shopping cart. So how does that affect the rate at which the object accelerates? Well, we're going to apply the same amount of force to each one. Okay, I'm just going to change my pen color here. Back to yellow. All right, so if we apply 400 newtons of force to each shopping cart, all right, as we increase the mass, the acceleration should decrease. Okay, so as long as force remains the same, the force applied to the empty cart will not have the same effect of the same force applied to the full cart. So look, so if I push this empty cart, all right, it's going to accelerate. Now, let's get our formula triangle up there. This always helps us. Okay, we have mass times acceleration. All right, we're given force and mass. Okay. Now, if we push an empty cart, it should accelerate with a greater velocity than if we push a full cart. All right? So, if we calculate that out, we have 400 newtons of force divided by 400 kilograms. Okay? You get an acceleration of 1 meter per second squared. Now, if you double the mass, okay, and apply the same amount of force, it's going to have the acceleration, because this is basically acceleration is inversely proportional to the object's mass. All right, so as you double the mass, all right, you have to have the acceleration. And you'll see this when we work the problem out. So we still have 400 newtons of force applied to 800 kilograms of mass. Okay? That creates an acceleration rate of a half meter per second squared. Now, notice we doubled the mass. Okay? We have the acceleration. If we triple the mass, all right, so if you look, 1,200 kilograms is 3 times more massive than 400 kilograms, okay, you're going to get 1/3 of the acceleration. So if you have 400 newtons divided by 1,200 kilograms, you get a rate of acceleration of 0.3333, all right, meters per second squared. Okay? Now, to go over this, it's due to inertia, meaning the object's mass, the full cart resists accelerating more than the empty cart because it has more mass. Like, look, you have a bunch of stuff in here. So the inertia, the mass, doesn't want to move. All right, and remember we said inertia is directly related to mass. So an object that doesn't want to move will just sit there. Think about it like this: if you went outside and you had a bicycle sitting there, and on training wheels, and you had a dump truck full of dirt sitting there in neutral, and you went up and pushed them both with the same force, the bicycle on training wheels will go flying across the parking lot. But the dump truck full of dirt, even though it's in neutral and no brakes are on it, you would push it and you're not even going to move it because it's got so much mass, which means so much inertia. It's resistant to change in its motion. Okay, and that brings us back to Newton's first law. Okay, so if you remember, Newton's second law said if you double the mass, you have the acceleration. If you triple the mass, you third the acceleration. It's an inverse proportion. So here you'll see if the mass, okay, if we did a t-chart, acceleration, if you double the mass, you have the acceleration. You triple the mass, you third the acceleration. You quadruple the mass, you fourth the acceleration. Okay? So you'll see this is called an inverse proportion. Okay? Okay, if you have any questions, please feel free to ask. I'll be happy to clear any questions you have up for you in class. Have a great day. Take care.